Hi there, welcome back to our course PETR3134, the codes and specifications in the petroleum industry. And today we're going to talk about the pipeline regulation in Canada. And as you know, as your project work, it's mostly about the natural gas transmission pipelines and it's the threat analysis. So you'll find it very helpful, this lecture today. Okay, so let's have an overview. So the Canadian pipeline system, it got in 2016 data, 840,000 kilometer, and I think it's over 1 million now. And the federal and provincial, both governments, like they have the regulatory bodies, and they have adopted the National Pipeline Standard, which is the Oil and Gas Pipeline System, CSA, or Canadian Standard Association Z662, the standard. Okay, so uh, this is actually not only a standard, it's also a code. Okay, it was a standard, but since the federal and provincial regulators, they have been adopted as a national pipeline standard, so it became a code. Okay, so the pipelines in Canada are designed, constructed, and operated accordance with the normative requirement of the common standard, which is CSA Z662, right? So let's learn how are the different types of pipelines we have. So we have the transmission pipeline, distribution pipeline, and the gathering pipeline. These three are the main different types of pipelines we have. Okay, transmission, distribution, and gathering. Okay, so except from these three different types of pipeline, we have some other pipelines like feeders and the flow line pipelines, but those are highly localized. So if anyone asks you like what are the different types of pipeline you have, so it's mainly these three different types of pipeline, okay, which are the transmission, distribution, and the gathering. Okay, so now, what are the transmission pipeline? What are the distribution pipeline? And what are the gathering pipelines? We know about these informations. We know about these things already. Okay, so as you know, transmission means it's actually transferring like a long distance. Okay, so this is the oil transmission, this is the gas transmission, and our project is actually based on the gas transmission pipeline. Okay, so gas transmission means like I will actually give you the example to the electricity, so you will understand it very clear. So for instance, near the Cape Breton, as you know, that's the power station. Okay, so for instance you have a power station, and from that power station you generate the electricity, and that usually the electricity volt is like a bit very high. It's like 10,000 volt. Okay, or you'll find it like even like 50,000 kVA, something like that. So what's happened, this this electricity then distribute, this transfer, so there's a transmission, long transmission pipelines, and sorry, the cables, and you'll find these big towers. Okay, with these structures, these big towers, so they actually hold these electric cables, and from there it transmit to the substations. And this substation, what the substation do, so the substation for instance is 10 kV kilovolt volt electricity, high voltage electricity, to downgrade it to like 440 or to 220 volt. Okay, and these we call like the substation, the industrial scale substation, and further it goes to the home. Okay, at this range, and before it going to the home, in Canadian standard we have the 120 volt. Okay, so it's downgraded again at the electrical transformer. Okay, and then it directly sent out to the homes. Okay, so this is the main procedure for the electricity. So this is the transmission, okay, of the electricity, and these are the distribution. network of the electricity. Okay, and what is gathering? Actually, gathering is something like, I mean, just right here you have generated the electricity within that line. When the line actually attached to the transmission pipeline, those called gathering lines. Okay, so these are the main different things. So now think it up just like gas pipeline. So in case of natural gas or oil pipeline, what's happened when you produce it from the gas oil or the oil wells, from there it directly go to the, in case of oil, it goes to the separator, right? So it goes to the separator at first, and the line it goes through the separator, those are the gathering lines. Okay, the same thing happened with the natural gas. With the gathering line, it goes to the gas processing plant, and here we call it the separation. And when the separation is done, okay, this separating is done in this oil processing plant, after that a portion of it actually goes to the gas transmission, the condensates, in here the condensates, here the natural gas liquids, those actually goes to the gas processing pipeline, and the crude oil, I mean, this is the crude oil. So the crude oil, it goes through the transmission pipeline to the oil refinery, and this through the oil transmission pipeline. Okay, and from the oil transmission pipeline, it goes through different distribution network. It could be through the vans, like the oil tankers, or to the through the pipelines, or different modes we actually use. And in this case, after the gas process, it goes to the natural gas transmission pipeline, and it goes to the distribution network, just like that. Okay, and here the at the gas transmission pipeline, the pressure, the differential pressure was very high. It was like, I mean, nearly like, I mean, 600 to 1000 psi. Depends on the diameter of the pipeline. Okay, and the diameter would be something like, sometimes it would be, for instance, like, I mean, 12-inch to even if 36-inch, something like that, or sometimes you'll find 8-inch. Okay, so this is the range of the transmission pipeline too. Now this is the transmission, these are the distribution, and in case of distribution pipelines, the pressure is downgraded, and the pressure became something like, I mean, nearly like, I mean, 15 psi, very slightly higher than the atmospheric pressure. Okay, so this is about like the transmission, distribution, and the gathering pipelines. Okay, now the low pressure distribution pipelines, these are under the jurisdiction of the provincial government. Okay, but the high pressure transmission pipeline, these are under federal jurisdiction, and the federal jurisdiction are the National Energy Board, or NEB. They actually are the oversight of the federal jurisdiction. Now some cross provincial gathering pipelines, okay, for instance, the gas well is in Alberta, or sorry, the gas well is in Saskatchewan, but the gas processing plant is in Alberta. Okay, so that kind of scenario we call this the sausage link. Okay, or like the cross provincial gathering lines. Now those are under the federal jurisdiction. Okay, and what if, like, I mean, you have a pipeline in you have a reservoir in Canada, and the pipeline actually go to United States, okay, from Alberta, for instance, the Keystone pipeline. Okay, so what's happened to that? Because the originated, it's from Canada, but it goes to states. So that kind of pipeline also under the jurisdiction of National Energy Board, or NEB. Okay, so the only provincial government got the distribution network of the pipeline and some portion of the gathering pipelines, if it's but mostly like the distribution pipeline is safe to say that for the provincial jurisdiction. But the high pressure transmission pipeline, the cross provincial gathering pipeline, and the pipeline that crossing the international boundary, all these different types of pipelines would be under the jurisdiction of the federal government, or the NEB. Okay, so these are some statistics of how much the natural gas and oil that Canada produce, and how much we actually consume, and how much we actually export it to our neighboring countries. Okay, so this is the map. You can actually check, like, what is the main source and which different places, and it actually moves in the markets. Okay, and these are like the proposed pipeline, existing pipelines and stuff. The infrastructure, well, this is the 2016 data. Okay, so remember that. So if the new data, it's different. It's even more. Okay, so the gathering pipelines owned by the producers, the transmission pipeline owned and operated by the oil and gas operating companies. Okay, and the distribution network is owned by the operating companies. Okay, that's also owned by the operating companies. So one of the operating companies is just like Enbridge. Okay, so they are one operating company, or even like, Husky is another operating company. Okay, so that's why you will find like the lots of the gas station, they have like the Enbridge, or like the Husky's operating and distribution. They have the large distribution network. Okay, but the transmission pipelines, these are also owned by the operating companies, but the gathering pipeline owned by the producers. Okay, now this is statistics on like how much a portion of the crude oil infrastructure we have, and for the natural gas. So as you can see, it's way more higher than the crude oil infrastructure. Okay, now in this case of the infrastructure, we have to be very careful about like what are the main cause of the threats of the infrastructure. Okay, so the NEB, it says like the external corrosion is one of the major threat of the integrity of the pipeline. Okay, so integrity means like the wellness of the pipeline. You can say like the followed by the cracking and the external damage, as you can see here, like the corrosion, cracking, and the other causes. Okay, so there are different causes. Now, in cracking is also a part of corrosion too. Okay, like the SCC, or stress corrosion cracking, is also a type of corrosion. So we have to be very careful about the corrosion, and that's why in these slides you'll find lots of discussion would be about the corrosion. Okay, so how we can actually prevent the corrosion, what are the cause of the corrosion, and what are the steps you can take to measure, or like to predict if the pipeline is more likelihood of getting corroded. So these will actually learn. Okay, now several pipeline accidents, including in 1985, the Cambrose, that's the worker died as a result of poor maintenance practice and the emergency response. Okay, so and in 1990s there are some stress corrosion cracking incidents too. So these actually led to make the recommendation of the integrity management in the CSSE 662 standard. Okay, so there are some links actually you can see. For instance, the first link, actually, if you click in this first link, then you will find it's very interesting. There's interactive pipeline incident data. So you can click this, just like for the United States, we have the integrity data at the, you remember, PHMSA, PHMSA website. In here, this is that for the Canadian counterpart. Okay, so how many incident we have for the first years, like 29 incidents, and what is the portion of the gas pipeline and the liquid pipeline, you can see. Okay, and which area these incidents actually happen and how these things happen. Okay, for instance, here if you click, you'll find Nova gas transmission pipeline, incident type fire. Okay, so you can actually get the information. And if you actually click more, then you can actually get like the more data on this incident, for instance. Okay, for instance, this one, if you actually click in here, this is a Trans Mountain pipeline. Okay, and here also the incident had the fire. Okay, so any type of incident will be noted in this website. It's a pretty cool website actually to see the visual data, the visual graphics actually. Now, NAB regulation. So, what is the I mean power, like I mean what to what extent National Energy Board or NEB got the regulation to the pipeline. So NEB actually got the pipeline for the whole life cycle of the pipeline. How? So just it's starting from the company's planning and pre-application process to the application of the assessment, construction, operation and maintenance until decommissioning. That means from the cradle to the deathbed of the pipeline, the NEB regulations will be activated, and that's why it said the full life cycle regulation. Okay, so it's very important, and NEB has a right to inspect and audit. The perspective means the monitoring the compliance in the construction operation phase. Okay, and to in order to minimize the safety and the environmental incidents. Right now, NEB decides what constitute a hazard and what needs to be protected. Okay, so that's NEB's job, and that's how NEB or the National Energy Board, they build the regulations, they update the regulations so that the oil and gas industries, the operators, and I mean all other companies, they should follow the NEB's rules and regulations. Okay, so about this, so these are the objective of the NEB. Okay, and which are the public health, safety and security and environmental protection. Okay, to promote fair and competitive market economy, make the decision based on scientific evidence. Okay, it's very important, not based on some emotion or something. It would be based on more like data driven. Okay, that's why we actually are very much keen on collecting the data and analyzing the data, not just I mean reading some newspaper articles written by some journalists who don't have much knowledge on the scientific data. So or like the um, um, any specialization on that field. Okay, so this is very important. So using precautionary principle as necessary and create accessible, understandable and responsive regulation, advance efficiency and effectiveness of the regulations. These are very important. So let's see what CSSG 662 adopted by NEB in Canada, what it got in general. So in general, CSA standard, okay, it's wide, it's variety. It's just like in the international standard ISO. Okay, so since ISO actually got lots of variety fields, actually CSA also got lots of variety field. Okay, in management, construction infrastructure, electrical, energy, environment, healthcare and medical devices, worker and workplace safety, technical safety, public and community safety, lots of different parts. Now in energy section, it got petroleum and natural gas industry, fuel burning equipment, alternative energy, vehicles, energy efficiency, nuclear and renewable energy. Okay, so all the energy would be under the energy, and within the energy we have the CSA 662 for oil and gas, like the petroleum industries. Okay, so as you know, it got the whole life cycle approach. Okay, so since it starts from the design, construction, operation, maintenance, and also to the till the decommissioning. Okay, so these are the overview of the CSA, and CSA standards are continually reviewed and updated. Okay, based on different parameters, technological advancements and best practices. Now let's see what are the scopes of CSA 662. Now the CSA, it cover, as we said, design, construction, operation, maintenance, and also the decommissioning of the oil and gas pipeline system. So it covers the liquid hydrocarbon, for instance, the gasoline, crude oil, multi-phase flow, etc. And it cover oil field and water system. Oh, it also include natural gas liquids and stuff. It include the oil field and water system, and it includes gases like natural gas, carbon dioxide, okay, and other gases used in oil field to enhance recovery schemes. Okay, so this is very important. Now let's see what are the clauses and annex we have for any CSSE 662. So, okay, so the CSSE 662, it got like the scope, definitions, the safety and loss management system, design, material, installation, joining, pressure testing system, corrosion control, the operation maintenance operation, the offshore steel pipelines, gas distribution system, um, different types of plastic or like reinforced composite pipelines. These used for the gas distribution system actually. Okay, or steam distribution system, aluminum piping, and different other types of piping and reinforced steel piping. Okay, so these are the clauses. Now there are so many annex actually within the NEC CSSE 662 system. One of the example I can give, the CSSE 662 standard, as you can as you know, like I mean, we have learned like the ASME P3134 for the process piping, right? Now in there we have learned how to calculate the pressure, you remember, and calculate the design wall thickness of the pipeline to prepare the design wall thickness. This is the formula for the wall thickness, you remember. Now in this case, how we actually calculate through CSSE 662. Now if you check this formula, then you will find there are lots of factors actually, okay, like F, L, J, T, which is like the design factor, location factor, joint factor, temperature factor. So that means like CSSE 662 got more precise different other factors to adjust the parameters. So that's why CSSE 662 is really it's better and everything. So what you can do, we have the previous examples in SPB 31.3 we have solved before, so you can actually solve within this CSSE 662 formula. Okay, I will upload all these standards in the model so that you can actually get much better idea on the standards. Okay, so these are the factors, okay, temperature factors, joining factors, and the location factors. So you can actually multiply these factors, and then you can actually get the thickness, wall thickness of the pipeline if the design pressure is given. Okay, now let's talk about our next topic, which is the next part of our topic, which is the oil and gas pipeline integrity and safety management. So we have briefly known, like I mean, why integrity is important, because NEP actually ruled that integrity is important because of the public safety. Now let's know more about the pipeline integrity. So for the safe and reliable operation of a pipeline, it is important to manage the pipeline integrity. Now, pipeline integrity, we also call it PIMS, or Integrity Management System. Okay, it's the whole system to provide the overreaching, the integrated framework for effective pipeline asset management. Okay, so sometimes you will also know, it might also called like the asset integrity also. Okay, because pipeline is part of the asset. Now, the pipeline failure investigation reports some catastrophic incidents like San Bruno in California 2010, and there's a lots of people actually died with these types of incidents. So after these types of incident happen and investigation has been done, after that the investigators, they have realized that it is important to identify the significant contributing factor that could cause these types of incident. Okay, so these are known as the pipeline threats. Okay, so pipeline threats, what does that mean? That means the different types of causes that that can uh, that can cause the different kind of contributing factors that can cause the incident. Okay, for instance, for our human body, what are the threats? Like coronavirus, it's a type of threat we have right now. Okay, so that actually attack us, destroy our immune system, and then it actually could be very, very dangerous for us. Okay, so the same thing happened to the pipeline. For instance, the external corrosion is one example. So what happened to the external corrosion? If that happened to the pipeline, if the external corrosion attack by if the pipeline is attacked by the external corrosion, at that time it degrades the pipeline's strength. That means the same to our immune system, it destroys the immune system. The same way it degrades the pipeline strength, and after the year what's happening, it can fail. Okay, just like in our cases, in case of human, lots of people died in case of coronavirus. So just like the coronavirus is a type of threat for us, the very similar way these threats like pipeline external corrosion is a type of threat for the pipeline. Okay, now we have to identify the threats, just like we have to identify what is the root cause of that virus. Okay, that's how our epidemiologists, they are working on the vaccine. Okay, so this very similar way we have to create a control measure for the pipeline. So we'll actually know about this also, like, I mean, how we can actually manage this threat. And just like we are actually managing the coronavirus the same way, we will actually manage these threats. Okay, to make the pipeline more safer. Now, the information on pipeline failure and the causes, these can be found at the FIMSA for the US Transportation Board, or National Transportation and Safety Board, NTSB. And for Canada, you can find at the NEB website that we just have seen a little bit earlier. Remember here, this one. Okay, and also you can find it the Alberta Energy Regulator. Okay, so there are different sources you can find. Now, these are the regulatory and standards for the pipeline integrity. Okay, the CFR 49 CFR Part 192 to 195. So this is like a US code for the pipeline integrity regulation. SPB 31.8S, that is for the natural gas transmission pipeline. API risk-based inspection system, or like the RP 580 to 581. So which is the inspection system to inspect. Just like for our human body, we do the coronavirus test or screening, or we go to the doctor and they screen. The same way we have to do the inspection to the pipeline, so that we should actually check if that pipeline, the segment of the pipeline is corroding or not. Okay, so this is the guideline for that. API standard 1660, NSE RP 0502, NSE is the National Corrosion, and CSS is equal to NXO, ISO, there's some ISO standard too. Okay, so these are the regulatory standards for the pipeline integrity system. Now, let's talk about risk management. Okay, and how this risk management actually are related with the pipeline integrity. We'll actually learn about that. So this is one of the book I have actually followed for the risk management. So risk management has been embraced by both pipeline industry and the regulatory agencies. Why? It is a way to increase the public safety, okay, and also optimize all aspects of the pipeline design, operation, and maintenance. Now, the focus of risk management is to establish a program that follows the industry's best practices, okay, and it gives the pipeline owner and the operator a long-term decision-making tool, and that installs public confidence about the pipeline safety, which is very, very important. Okay, so public, I mean the general people, they have to know, like, yes, the pipeline is safer, a safe mode to transport the oil and gas things. So that's exactly why we have to do the risk analysis, and from there we can actually give the data that, okay, so the pipeline the incident rate of the pipeline is much lower than any other transportation mode. Okay, so that's why it is more safe. So that's how public will have more confidence, and when public will have more confidence, they will not they will actually endorse of building the pipeline rather than protesting of building the pipelines. So this is very, very important in that reason. Okay, so the when for instance, one of the example given in here, like the assessment of the pipeline integrity. So SYMS or SMICE is a measurement of the yield stress. Okay, so the minimum yield stress pipeline actually got, sorry, the minimal specified minimum yield stress a pipeline have. Okay, so that means if the yield stress or SMICE is above 60, okay, if the I mean the pipeline operating with the above 60, then the inspection should have to be done after each 10 years. Why? Because for instance, your this is your limit, 100 is your limit. Okay, you are running a pipeline within like the capacity of 60, so that means you are actually giving more load to the pipeline. Okay, so that's why you have to do the inspection after within each 10 years later. Okay, so the first inspection after the construction with after 10 years. But if your pipeline's load is like below 30, for instance, okay, but your minimum yield strength is like 100, so that means you are running in less load. So less, that means you have your pipeline is more like safer condition, you are actually giving less stress to the pipeline. Okay, so in that case you can actually do that after 20 years. So this is a kind of like qualitative way we have determined the thing the inspection period. Okay, so one of the example of the how we actually develop these types of data. Now, what is risk? So the risk is actually defined as the probability of failure times the consequence. Okay, so this is how we actually define the risk. Okay, so the POF times the COF, that means the probability of the failure of anything and the consequence of that failure. If you time these two, if you multiply these two, then you will find the risk. Okay, how we can actually see that? For instance, the probability of what type of example I can give? Just give an example. Okay. For instance, you have a new television. Okay. Now, the probability that your television will fail, okay, is, for instance, just